Hi guys, this is section 7.6, which is systems of linear inequalities. If you remember when we graphed systems of linear equations, you had to graph two lines and you find an intersecting point, and that was the solution. Well, systems of linear equalities is going to be the same thing. You're going to graph two lines, but if you remember inequalities, you have to shade one side or the other. So the solution is going to be where you, instead of where you intersect, it's going to be where you double shade, and I'll show you what I mean. If we're graphing x is greater than or equal to 3, that is going to be a solid vertical line, and this is all a review for you guys. And it should be, because it's greater than or equal to, it's a solid line. Greater than means I shade to the right. If I were you, I wouldn't shade it all completely. I just kind of give yourself a little marking so you know you're shading to the right there. Okay, so I would just kind of go like this so you know, because you might have to end up erasing. For the y is less than -2, that one is going to be a dashed line. Okay, so you're going to see on the graph paper, it's going to be hard to write a dashed line because there's going to be lines on the grids. So what I want you to do is, and you have the option, when you draw your dashed line, you can still draw the solid line, but then go ahead and train track it so you know that that means dashed. Okay, so train track means it's a dashed line. It's just going to be much easier for you when you have grid lines. Okay, and if it's less than, that means I'm going to shade below the line. Okay, so what I need to do now is look, where is the common area where I shade to the right of the green and below the purple, and that would be over here. And so this is the only section that would be double shaded, and so I'd actually erase this and erase that, and so the only part that's should be shaded is where it's true for both of these. Okay, so it's a double shaded area. It's there to the right of the green and below the purple, and that's the solution. Okay, I'll do a couple more just so you can kind of see, get this. Here's one where I have different inequalities. So 2x minus 4, I start at -4, I go up 2 and over 1, and then I go up 2 more and over 1 more, and I'm going to draw a dashed line. Okay. Sorry, it goes a little crooked, I can see that. The green line is y is less than or equal to, so that's going to be a solid line. Start at 3, you go down 3 and over 4, so it's going to be here, and I'm going to draw a solid line. Okay. Notice I got pretty long lines too, so you can see. The purple line I'm going to shade above the line because it's greater than, so I'm going to shade above it. And the green line I'm going to shade below it, so I can see if it's above the purple and below the green, it would be in this big section here. And I would erase this side. Okay, so you can see that's where I would be double shading. Below the green and above the purple. Okay, and one more graphing, and I'll show you how to write linear inequalities. By the way, you can see at the top it says graphing systems of linear inequalities. Okay, so here's the last one, and then we'll write linear inequalities. The purple one is -x plus 2, so it's here. I go down 1 over 1, up 1 over 1, and it's a solid line, and it goes like that. Okay, the green one is going to be x plus 4, so I start at 4, and it's a positive x, so I'm going to go up 1 and over 1, down 1 and over 1, and it's going to be a dashed line. Okay. When I shade, I'm going to shade above the purple and below the green. So above the purple, below the green, I can see that this is where it's going to be double shaded. So above the purple because it's greater than, so it's all to the right. Below the green because it's less than, below, and that red area is where it's double shaded. So that's your solution. So any point in this, so for example 4 comma 0, that would be a solution for both of them. I could choose 4 comma 4, this point right here. That would be a solution as well. And if you try 0 0, it will not work for both of them. It will not work for, if I put 0 here, that's true, but if I put 0 here in the purple, oh sorry, you cannot see, that would be false. Okay, so again, it has to be true for both of them. Okay, so here is how you're gonna write systems of linear inequalities. Let me go back so you can see. And I tried to make big graphs so you can see. So the first one I want to do is this one. I'm going to do a purple line and a green line. So the purple line is, it's a vertical line. I know that's an x because there's not going to be a y in it because it's an undefined slope. I'm shading to the left of the purple and it's dashed. Left and dashed means less than. And I can see it's at -3. So that's the first one. The green one, I can see it's shading below and it's a solid line. So already I know it's going to be y is less than or equal to. Okay. I want to find my slope. My slope is rise 3, run 2. So 3 over 2 is my slope. And my y-intercept is 1, 2, 3 plus 3. And that's how you write that system. Okay. If you didn't get it, don't worry. I'll do another one over here. The purple line, again, it's a horizontal line, so my slope is 0. So it's going to be y. And since I'm shading below it, you can see the red is below, and it's a solid line. Low and below means less than or equal to. I mean, solid and below is less than or equal to. And I can see it's at -1. Okay, so the purple line is y is less than or equal to -1. The green line, I put the y. I can see it's dashed, and I'm shading above it. Even though it's slanted that way, this red is above the green. So dashed and above means greater than. Okay. My slope, I can see it's down 3 and to the right 1. So -3x is my slope. And my y-intercept is 1, 2, 3, so plus 3. And that's how you write systems of linear inequalities when you look at a graph. Okay, the last part, and this is it, is real life problems or real world problems. And then graphing it. So Dane is making a look. The length has to be at least 80 feet. The perimeter can be no more than 280 feet. What are the possible dimensions? So I said x is equal to the width, y is equal to the length. Here's my length here. So if the length has to be at least 80 feet, my first inequality could be y is greater than or equal to 80. Okay. If I wanted to graph that one, the length is at greater than or equal to 80, it would be a solid line like that. So that's how you would graph the green one. Okay, the perimeter, I'll do this one in purple, would be 2x plus 2y can be no more than means less than or equal to, and 280 feet. Okay, because 2 times the length plus 2 times the width is less than or equal to 280. If I just did x and y intercepts, 2y is equal to 280. If I divide by 2, I can see x is going to equal to 140 and y is going to equal to 140. Okay, so what I would go to the 140 over here, the 140 over here, graph that. Okay, and again, it has to be greater than or equal to 80, which is above the green line, so everything above the green line. But it has to be less than, because it's over here, less than or equal to the purple line. And so my shaded area would be, and I'll just make it smaller, this area here. So anything in there would be okay. So 20 for the width, 100 for the length would be okay. If I chose, sorry, I'm gonna make it, I could choose that dot, 20 comma 100, or 20 comma 120. That would work. Any coordinates within that would work. Okay, so that's how you set them up. I would highly suggest looking at the other word problem example. I didn't want to take the time, I want to keep this short. So look at the other word example about the stamps, and you can see the values again. You guys should be pretty good at writing equations. There is no homework check on this one. Okay, so I hope you guys have a great day.